This video is aimed at helping you to draw a mechanism for an electrophilic addition reaction. Firstly, what do these two terms mean? Well, addition simply means two molecules becoming one. And an electrophilic refers to an electrophile, which is an ion or molecule that attacks regions of high electron density. This can simply be a positive end or a delta positive end of a molecule. So, now that we know what an electrophilic addition reaction is, let's have a go at an example between ethene and hydrogen chloride, HCl. As I mentioned earlier, a vital component of any organic reaction mechanism is a key. And our key for this reaction is that this arrow represents the movement of two electrons. The arrow shows that electrons are moving from somewhere to somewhere else. In this case, we must consider where electrons are in demand and where there are lots of them. Our C+C indicates a region of high electron density. This region of high electron density gets attacked by our electrophile. So our electrophile in this case, it must be the HCl molecule, or indeed part of the HCl molecule. We find, first of all, using our electronegativities, that hydrogen is electropositive in this molecule, and our chlorine is electronegative. Straight away, we've identified that this is our electrophile. The H, the delta plus, is the region that attacks the C double bond C. Our key shows that electrons move from the double bond, where there's lots of them, to where there are less of them. From here to here. As a result, the two shared electrons previously between the hydrogen and the chlorine are relinquished by the hydrogen. It is extra electrons from the double bond. Note our arrow shows two electrons. So these pair of electrons move on to our chlorine atom, and as a result turn it into a chloride ion, negatively charged with extra electrons. Now, this type of fission is called heterolytic fission. It results in the formation of two different species. Our dashed arrows show the movement of progression into the next step of our mechanism. And as a result of this arrow, we have now formed a new bond between the carbon and the hydrogen. Our molecule now looks like this. With a single bond between the two carbons, and this carbon on the right with two hydrogens attached. However, it's also experiencing a lack of electrons. Previously here, it had two shared pairs of electrons. Here, it now only has one, and as a result, has a strong positive charge. This species is called a carbocation. Carbo for the carbons, cation for the positive charge on it. Well, no coincidence, but when positives and negatives meet in chemistry, they tend to attract each other. Here, two electrons are attracted to the positive charge on our carbocation, leaving us with our product. From AS Module 1, we should have learnt that these type of bonds that we have made, in which both electrons come from one atom, can sometimes be drawn like this. These are known as dative covalent bonds, or coordinate bonds. And our product, known as a halogenoalkane. Rewind the video if you like, and try drawing this mechanism for yourself.